Alright, today we are talking about our trig ratios again. That is sine, cosine, and tangent ratios. You can remember that with the acronym Sohcahtoa. The only difference between today and previous lessons is we're just going to go a little bit more in depth, have some more complex fractions going on with our radicals. So let's take a look at this first problem. The directions say find all three trig ratios from the marked angle. So our marked angle would be this theta right here, and we're going to find the sine of theta. We're going to find the cosine of theta. Oops, misspelled that. Let's try that again. The cosine of theta and the tangent of theta. So remember what we got to do here. For sine, that is our O over H. So let's label our sides. Across from our right angle is our hypotenuse. Across from our theta is the opposite side, and then closest to that is adjacent. So my O over H is 16 root 2 over 24. Now when you are simplifying this, remember outside a radical to outside of a radical. These are both divisible by 8, so I'm going to simplify that to 2 root 2 all over 3. And that is done. Our cosine of theta, looking at it, I've got A over H, that's my co, so A over H, and that is 8 over 24. Those are both divisible by 8, so I'm going to reduce that to 1/3. Now here's where it comes into play right here. We've got our TOA. We've got 16 root 2 all over 8. Now this radical right here is okay, it's in the numerator, but you've got to go ahead and simplify right here, 2 root 2. So had this radical been in the denominator, we would have had to rationalize. So let's see what goes on with this next one. We've got our theta right there, so this is our sine of theta, our cosine of theta, and our tangent of theta. So I've got opposite, hypotenuse, and our adjacent side. So to start with, I've got 4 over 6, which is 2/3. Again, if you're wondering about that, that is O over H, so O over H sine. My cosine is my cos, so A over H, so 2 root 5 over 6, which is going to be root 5 over 3 when we simplify. And finally, my tangent, that is my O over A. Here it is, 4 over 2 root 5. So there are a couple things that need to go on here. So that answer is not good enough. So one of the first things that needs to go on is we need to simplify right here. So 4 over 2 is really 2 over 1 root 5. And then I need to rationalize. So I need to multiply both the top and bottom by that root of 5. Smart work right there. My tangent of theta equals 2 root 5 all over right here. That becomes the root of 25, which is just 5 left over. So the tangent of theta is 2 root 5 over 5. You've got 2 more problems left. I suggest you pause the video, try them on your own, and then skip ahead to the answers. But if you need to, stay right here, and I'm going to work all of them for you. So we're on this next problem right here. I've got my theta right there. I need my sine of it. I need my cosine of it, and I need my tangent of it. So with my I need to go ahead and label my sides. We've got our hypotenuse across from my right, across from my angle is my opposite, and then my adjacent is right there, side by side. Sine, O over H, so O over H, that's 7 over 21, that's 1/3. Cosine, that's A over H, so I've got 14 root 2 over 21. So far, so good. Divide by your 7. So 2 over 3 with a root 2 on top. And my tangent, O over A, there's my radical again happening in the denominator. So before you get there, make sure you simplify your fraction. It's 1 over 2 root 2. And now we can rationalize. So when you're rationalizing this one, don't take this 2 along for a ride here, this one right here. You only want to get rid of the radical. You like that too. So we're going to multiply the top and bottom by the root of 2. 1 times the root of 2 is just root of 2. 2 is sitting outside. Root 2 and root 2 make the root of 4, which all together makes 2 again. So we really have 2 2's sitting down there. This 2 and the 2 we get out of this. And now just multiply that together. So we've got root of 2 over 4. So the tangent, let's go back there. The tangent of theta is really the root of 2 over 4. All right, we got another one coming up right here. Let's try that out. We've got our theta right here. So we've got our hypotenuse across on the right, our opposite across from our theta, and adjacent touching it right there. So my sine is my SO. So my sine of theta is O over H. So we've got 24 over 12 root 5. So here's the first one where we've got to rationalize right there, right off. So I'm going to simplify this fraction right here. That's 2 over 1. And now we've got to rationalize the root of 5. So that's 2 root 5 all over root of 25, which is just 5. Okay? Now let's try our cosine. So my cosine of theta is our A over H. So I've got 12 over 12 root 5. So my 12's cancel. I just got a 1 on top. And then I need to multiply both top and bottom by the root of 5. So I've got 1 root 5 on top. Just a root 5 if you write that simply. And then 5 and 5 make root of 25, which is 5. So final answer there is the cosine of theta is root 5 over 5. And then our tangent, it's O over A. So I've got 24 over 12. That's an easy 2, but we usually like to keep it as a ratio, so keep it in there as 2 over 1 for me right now. Okay, so next problem looks a little bit more complicated. I want you to write all the missing trig functions. So I give you sine. That means we still need cosine, and we need tangent. If I gave you cosine, then I'll need sine still, and tangent, and so on and so forth. So what we did is I've only given you 2 of the sides, and we need 3 sides really, because we need an adjacent, a hypotenuse, and an opposite. So what you need to do is draw a picture of a right triangle. So I'm just going to draw a classic right triangle right here, what we normally think of. And I'm going to label whichever angle I want X so that it makes sense with this. I'm going to label this one down here. And if I told you the sine, then I told you the SO, which is opposite over hypotenuse. So based off of this angle right here, I gave you the opposite and the hypotenuse, which is 40 over 41. So what you need to do is go to your calculator and do the Pythagorean theorem for your adjacent side. So we've got our missing side, let's call it A for our adjacent. So we've got A squared plus 40 squared must equal 41 squared. When you put that in, you get 40 squared is 1,600. 41 squared is 1,681. So solve this real quick. You get down to A squared is 81. So we know that A, our adjacent side, must be 9, the square root of 81. So let's go ahead and finish this up then. If I have the cosine, I was already given the hypotenuse here, 41, but now we know what the adjacent side is, 9. We solved for that with the Pythagorean theorem. And my tangent, that's my TOA. So I need the O over the A. So my opposite is 40. My A, 9 that we solved for with the Pythagorean theorem. Alright, if you feel comfortable enough, go ahead and try the other 2 on your own. If you need to see some more, right here is where you need to be. So for your cosine, means I gave you the cos. So let me just draw, again, just our classic right triangle. Label whatever you want theta. And label our sides off of that. So opposite, hypotenuse, and adjacent. So I told you the cos, 1 to 2. So 1 to 2. So our Pythagorean theorem this time is going to look a little bit different. I'm just going to call this one X since I don't have an X in this one already. We've got our squareds there, and then our x squared is equal to 3. So we're looking at a root of 3 there. So this side right here is a square root. So this is kind of bringing in all the stuff we've done. It has Pythagorean theorem, has radicals. When we go into our sine and tangent, I'm sure there's going to be times where we're going to have to rationalize. And that's about everything we've done this unit. So let's try it out. So my sine, O over H, root 3 over 2. Alright, no rationalizing yet, that's fine. And then our TOA, root 3 over 1. Or just say root 3, it's up to you. I'm preferring the ratios right now since I asked for ratios, so as a fraction. And we're done. So we lucked out on that one, no rationalizing. Alright, let's try our next one. that says the root of, I think that's a 3. I'm having trouble reading it though, but let's say that's the root of 3 right there, over 2. So tangent is our TOA. If I have tangent, then I need my sine and my cosine. So let's go draw that triangle. Again, if you want to try this one all on your own, that's fine. Here's my angle A, and that's the one I'm going off of. So I've got my opposite, my hypotenuse, and my adjacent. If I gave you the tangent, then I gave you O over A, TOA. So I know this is root of 3, and I know this one is 2. So let's go solve real quick for my missing side. I've got 2 squared plus the root of 3 squared equals c squared, or hypotenuse. So that's 4 plus 3. Remember, squares and square roots cancel out, so just 3 equals c squared. So I get 7 equals c squared. Take your root, and we've got a root of 7 is our missing side there. Okay, so let's go for it. Sine, that is our opposite, so our opposite over hypotenuse. So we've got a root of 3 over the root of 7. Lots of radicals there. So as few as we had up here, now we've got them all over the place. So we've got to rationalize that. The only radical we don't like is the root of 7. So get rid of it. Radical times a radical multiplies. So we've got 21 of them in there. Those are both prime, so I know I can't break that down and simplify it. And then on the bottom, root 7 and a root 7 make the root of 49, which is just a 7 left over. So all done there. Let's go to our cosine. That is our A over H. So adjacent over hypotenuse, that's 2 over the root of 7. So again, rationalize. Go ahead and do your work right here. So I get 2 root 7 all over 7 again. There we go. Alright, on the back of this, you have some more practice. You can check your answers on Google Classroom. I just want to point out number 2, number 3, and number 4, you are going to have to go ahead and solve the Pythagorean theorem for each of those. So it's very similar to these types of problems we were just doing. I just already drew you a picture. Alright, good luck.